Hello students, we are discussing the chapter indefinite integration, and in this module we are going to see a derivation of a standard formula, and that is for integral of root of a square minus x square dx. Let us see what is the question like. The question says prove that integral root of a square minus x square dx is equal to x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a plus c. Now my dear students, before I start the proof, let me tell you it's a very important proof and it's a very common question in the exam for 4 marks. So you should know this very nicely. Let's see the proof. My dear students, they have asked us to prove that integral of root of a square minus x square is so and so. Now, how do I proceed to integrate? Here, we are going to apply u into v rule. But as you may see, we have only one function. So obviously the other function will be taken as 1. So we have the integral as root of a square minus x square into 1 dx, and as per the rules we will take the root of a square minus x square as u and 1 will be taken as v. Let's apply the u into v rule. So as per the rule, can I say the next step will be root of a square minus x square integral 1 dx minus integral d by dx of root of a square minus x square integral 1 dx the whole dx. Is that okay? Now my dear students, in the next step, can I write x into root of a square minus x square, because integral 1 dx is x minus integral. Now what is d by dx of root of a square minus x square? It's a composite function, so let me just help you. Let's take it separately. So we get root of a square minus x square on differentiation will give me something like 1 upon 2 root of a square minus x square into derivative of a square minus x square, which is minus 2x. So therefore, in the next step, inside the integral, can I write minus 2x upon root of a square minus x square? Please do not forget, integral 1 is still remaining. So can I write into x again? Okay, and dx is as always there. Now my dear students, let's simplify this. Now the thing I can think of is cancel the 2 inside the integral. So what should I write in the next step? X into root of a square minus x square remains as it is. We keep the minus inside. There is a reason behind it. So minus of x into x upon root of a square minus x square. Now my dear students, in the next step, can I write minus of x square inside the integral? Correct? Minus of x square inside the integral upon root of a square minus x square. Now my dear students, the bracket there should give you some hint, because I want you to remember something. If I check the degree of the polynomial in the numerator, it is 2. That in the denominator, ignoring the root sign, can I say it is 2? That is, degree of numerator is equal to degree of denominator. Degree of numerator is equal to degree of denominator. So, can I adjust? And to adjust, what we do is we add, subtract a square in the numerator. Adding, subtracting a square gives me a square minus x square, which is what was desired. Now let's see the next step. In the next step, what we are going to do is we are going to separate at minus a square. So let's write x into root of a square minus x square minus, and let me put brackets here because we are going to separate. Now when I separate, I get root of a square minus x square. How come? Because a square minus x square upon root of a square minus x square will be nothing but root of a square minus x square, and then minus of a square upon root of a square minus x square and a dx. Is that okay, my dear students? So let me keep the first half as it is. Let's open the brackets, or let me say let's separate the integrals. So I get minus integral root of a square minus x square and a minus of minus, so plus a square integral 1 upon root of a square minus x square dx. Is that okay, my dear students? So let us write x into root of a square minus x square minus, can I say this integral root of a square minus x square is nothing but I. So let's write a I here, and plus a square sine inverse of x by a plus c, 1. Correct? Now my dear students, we want the value of I. So let's take this step for reference. Can I say the left hand side is a I, the right hand side also has a I. So let's collect the I terms together. So on the left hand side, can I write a 2I? The right hand side remaining the same as x into root of a square minus x square plus a square sine inverse of x by a plus c1. Now just divide by 2 to get the value of I. So we'll get I is equal to x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a plus of c1 by 2. So in the next step, can I write integral root of a square minus x square dx is x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a and a plus c, where c is nothing but c1 by 2. And this is what they had asked for, and that's our final answer. A very important proof for 4 marks. Please go through it very nicely once again. That's all we have in this module. Thank you very much.